My experience is in the latter part of that, the sense of prevention and design through earthquake engineering. And I just really wanted just to talk about a few projects and 3 events that have sort of shaped my own understanding of earthquake engineering. The first of all, I was involved in 1999 when the Chi earthquake happened in Taiwan. It just so happened at that time I was involved in a company that was tendering the high-speed railway. The high-speed railway in Taiwan is a 350-kilometre high-speed railway from the capital city Taipei down to Kaohsiung. And we had just finished the tenders and they had just awarded the contracts for that project. And what happened between at the very start of the contracts was the Chi earthquake happened. And that earthquake was a very significant earthquake in Taiwan. And the picture you see there is some of the damage. I mean, you know, the waterfall that's there wasn't a waterfall before the earthquake. So, in fact, there were ground movements of something in the order of 7 meters in places. Which, and obviously you can see the bridge in the foreground. That bridge collapsed. I think something like, I haven't got the notes that came with this, that I had with this, but I think it was something like 2,000 people were killed, something of that order. 40,000 homes were destroyed, and as you can see, vital infrastructure was also destroyed for a period of time. I think this is one of my favourite photos of the earthquake, if you can have a favourite photos of earthquakes. This is the high school running track, and I think probably if you Google the earthquake, it's probably the first photo that comes up. But I think it's a great example of some of the damage that can occur. Obviously, that running track was flat before the earthquake. It certainly isn't now, and in fact, you know, it's actually now part of the earthquake museum in Taiwan. So they've actually made that particular incident and that particular area into a tourist attraction, which was quite interesting. That museum is really there to educate mainly the local population on earthquake design. I don't know whether anyone's been to that museum. Fortunately, I never got back to Taiwan after the railway opened. But not that said, we did build the railway. One of the things that happened as a result of the Chi earthquake is that the Taiwan High Speed Rail Corporation, there was a bit of a hiatus in the design whilst they considered the impact of that particular earthquake on the seismic design criteria for the project. And in fact, what happened was that they completely revised their seismic design standards in Taiwan, and in the area we were working, that resulted in an 18% increase in the bedrock accelerations. So obviously it would have had a massive effect. What was interesting is then I got involved a bit later on because they decided that rather than suffer that huge increase in cost that would have resulted from that increase in seismic accelerations, they decided they'd look at performance-based design. So I then got subsequently involved about 4 years later in a project to look at effectively post-assessment of the structures that have been built to work out through performance-based methods which of them would need retrofitting. So actually there were a number, not all of them, but a small number of structures that then were retrofitted after they'd been constructed, which was an interesting approach, but it did avoid, you know, the everything being designed for that higher earthquake in terms of, you know, the sort of traditional design approaches. So that was Taiwan, and that really for me was quite a major influence. What it demonstrated to me, with, as you can see from these viaducts, they've been operating since I think it's for over 10 years now. What it demonstrated to me was that with the right design, you know, major infrastructure projects can withstand massive earthquakes, and I know obviously this has withstood quite a few earthquakes since. Having said that, you know, there have been a number of earthquakes since in Taiwan where structures have collapsed. So there clearly are a number of structures, and we see this throughout the world, where, you know, maybe the modern standards have been applied to more recent structures, but certainly all the historic structures, whether they be masonry or whether they be, in this case, reinforced concrete, are not up to modern standards. So that was an earthquake in Tainan province in February 2016. As you can see, very, very significant damage occurred there. I'm not quite sure what happened in terms of loss of life, but I imagine there must have been some in that case. The second area, or second country, or second region, I suppose, where I've had some experience, and actually our company's had quite a bit of experience. Not actually in Nepal, and I think it's who's going to talk about Nepal. I think it maybe was Josh that's going to talk about Nepal. The Nepal earthquake, I hope I'm correct, Josh, I'm sure you'll correct me if I'm wrong, happened in April 2015. And, I think we all saw the pictures and we all heard the news about the number of people who lost their lives and the significant devastation that occurred across Nepal as a result of that. What perhaps people don't realise is the effects of that earthquake were felt across the region, actually. I'm just picking up Bangladesh. Apparently, 2 people were killed in Bangladesh as a result of the Nepal earthquake. And that's my very tenuous link, actually, to some work we did for the Roads and Highways Department in Bangladesh in 2010, obviously a long time before the Nepal earthquake. But we were engaged by the Roads and Highways Department to assess 2 quite long bridges. One was 900 meters long and one was 1.5 kilometers long. They very much are lifeline structures in Bangladesh because they cross some of the major rivers on the periphery of Dhaka. And what was happening was that they'd come to a realization that some of these earthquakes, particularly these regional earthquakes, could potentially have an effect on some of their major structures. And so they were going through a program of actually looking at structures that were 10 years old. I mean, this was only 10 years old, and actually working out, would it withstand the earthquakes? Bangladesh has a reasonably good seismic design code, but I think it's very true to say, and that's probably true for a lot of countries of that type, that whilst some of the major structures or the major new structures are being designed to it, there's a lot of unregulated building work that goes on and that doesn't comply with good seismic design practice, and therefore makes those structures very vulnerable in earthquakes. Anyhow, we assessed both these structures and found that there were actually quite serious deficiencies with them in terms of their earthquake resistance. And a lot of it came down to detailing, and this is perhaps the second thing I learned, that seismic design is not so much necessarily about the strength of the members, and I think that's important, or even the ductility of the members, because that's very important. A lot of the time it comes down to getting the detailing right, and one of the major things we found wrong with these bridges was the fact that where the spans were simply supported, they simply weren't tied together. So in the event of an earthquake, the spans would have just unseated, very much like the bridge that I showed you at the very first slide in Taiwan. So in fact, at this very point in time, those 2 bridges are being strengthened as part of a Japanese aid-funded project, and I believe that they are doing all the work that we recommended in our reports. So that, if you like, is my second lesson. Detailing is very important. Perhaps the third earthquake I just wanted to refer to quickly is one that I think we all know about, the earthquake that happened off the coast of Sumatra. That's a subsea earthquake, but it generated the massive tsunami that was felt throughout. Happened on Boxing Day 2004, and I'm sure you're all aware of where it occurred, but perhaps you're not aware of quite how far-reaching the damage was. It went all the way out to the east coast of Africa, into India. Obviously, Sri Lanka was very badly affected, but Indonesia itself suffered terribly. And in the aftermath of the Banda Aceh was particularly badly devastated. I think there's some, you only have to look it up and you'll see photos of completely flattened homes. But I found this photo and I thought that was quite interesting. That their disaster recovery equipment that they used in Banda Aceh, perhaps not what we'd see in some countries or the way we'd see it being done in some countries, but that's one of the things that they did. I think one of the things, and that really links to the sort of final project of ours that I wanted to talk about. We're currently, and have been designing for the last couple of years a section of the Jakarta Mrt, and a lot of the design that we've been doing for that has been seismic, and it's certainly controlled the design of the viaducts and the stations that we're designing there. Our contract is just one of a number of contracts, and as a company we're designing 4 kilometres of viaduct and 4 quite significant stations on it. As you can see from the photo, it's well under construction. In fact, we were talking about it earlier. I think the viaducts are now near complete. Stations are still ongoing. But certainly the seismic standards that were applied to this project were quite sophisticated. Again, it was Japanese funded, and we had to supply all sorts of seismic standards, not just for in terms of, if you like, an ultimate earthquake, but we had to look very carefully at the question of trains derailing at sort of service level type earthquakes. So we've done a huge amount of work on that. And again, what it demonstrates is the growing awareness, even in countries that, Jakarta don't think's ever had a massive earthquake, but I think, there's a growing awareness that there is a need to protect vital infrastructure from earthquakes in these regions. And also, I think there's a political imperative as well to be able to say to people, actually, the structures you're seeing built are earthquake protected, or certainly can withstand the largest earthquake that we can currently envisage. So I think, one of the things I've learned just overall is that, structures can be designed for earthquake. Detailing is really important, but it's still very much true that the projects that I tend to see tend to be the much larger scale infrastructure projects, whereas I think where the major loss of life tends to happen is for the much smaller scale buildings and residential sort of properties.